Hi girls and boys, hope you are fine? Good. I hope you understood what we discussed in the last class. So, before I begin this session, I am just going to recall what we discussed in the last class, right. So, we discussed what about mixtures, homogeneous and heterogeneous mixtures we discussed. Then we discussed about solutions and how we classified solutions on the basis of the number of components in it, and as well as on the basis of the phases of solute and solvent also we classified the solution. And in the end we discussed different methods for expressing the concentration of solution, both qualitative and we just started quantitative method of expressing the concentration of solution. So, last class we actually ended it with the discussion regarding using percentage as one of the method to express the concentration of solution, right. And in that we discuss mass percentage, we discuss volume percentage as well as we discuss the mass by volume percentage. Okay. Today we will be continuing that session with the remaining methods to express the concentration of solution. Shall we continue? Okay, come. So, next we will be discussing on parts per million. Parts per million is nothing but the number of parts of the solute present per million parts of the solution. That means you can write parts per million is equal to what? Parts of solute divided by total parts of solution into 10 raised to 6. That is, for every 10 raised to 6 parts of the solution, how many parts of the solute are present in it is given by parts per million. So, if you look at this, it is too small, right? Too small. Why it is too small, and when we are using this, it is especially used when the amount of the solute present in the solution is very, very less. When we use this method to express the concentration, particularly when the amount of the solute is very, very less. The amount of fluoride ion present in the drinking water, you know, it is a poisonous ion, it can seriously affect your health if it is present in the drinking water. So, if the concentration of fluoride ion in drinking water, if it exceeds a particular limit, it can be dangerous. So, normally the amount of that fluoride ion in water, drinking water should not exceed 1 parts per million. Okay. Now, you can also use this unit for expressing the concentration of the different poisonous gases which get contaminated in the air that we breathe. So, the parts per million you can define it as 1 part per million is 1 part by weight or volume of solute. That means you can express the amount of the solute either in terms of mass or in terms of volume, and you can see if you express in terms of weight and volume, that is in terms of weight and volume if you want to express, how you have to do it. See, 1 parts per million can be defined as 1 gram per meter cube, okay, which is equal to 1 milligram per liter, or which can be 1 microgram per milliliter. So, that if you look at this, it will be equivalent. Okay. Now, in weight by weight if you are expressing, that is 1 parts per million will be equivalent to 1 milligram per kilogram, that is 1 milligram of the solute per kilogram of the solution, or it can be expressed as 1 microgram of the solute per gram of the solution, right. Now, let us try solving this question. Okay. So, can you read the question? A solution has a concentration of 1.25 gram per liter. It has a concentration of 1.25 gram per liter. What is its concentration in parts per million? Understood? What is its concentration in parts per million? What is given? You are given the concentration of the solution in terms of weight per liter, 1.25 gram, that is 1.25 gram per liter. Now, you know that So, what is the amount of solute? Okay. What is the amount of solute? Amount of solute is equal to 1.25 gram per liter, right? But you know, you can make it in terms of parts per million. You see, 1 ppm is equal to how much? 1 milligram per liter, right? 1 milligram per liter. So, what we have to do is simply convert this 1.25 gram, which is already given in terms of liter, into 1.25 gram has to be converted to what? In terms of a milligram. You know, it is very simple. You can multiply that 1.25 gram into 1000, right? So, amount of solute in milligram, how much? It is 1.25 into, this is in terms of gram, right, into 1000 milligram by gram. So, you can cancel it. So, what you get is 1250 milligram. So, this much amount of solute is dissolved in how much liter? 1 liter. So, here it is very clear your concentration of the solution is in terms of parts per million, you can say it is 1250 ppm. Okay. So, you are now expressing the concentration in terms of parts per million as 1250 parts per million. Hope it is clear to you. Shall we go to the next one? Okay. Next we will discuss what is mole fraction. What do you mean by mole fraction? It is simply a fraction. You know the concept of fraction, right? So, out of a whole, what part a particular component comes, that is what you call fraction. Now, in terms of mole fraction is nothing but the fraction of moles of a solute present in the total amount of what? Total amount of solution. Okay. Now, for example, how can you write it? See, since it is in terms of moles, you can say number of moles of a component divided by total number of moles of solution. You need not multiply with anything because it simply represents the fraction, right. So, if I say in terms of number, let you be having two components A and B, you take a binary solution A and B. Now, let Na represent the number of moles of A and Nb represent the number of moles of B, then you can write mole fraction of A, we represent using the letter X or chi. Chi A is equal to Na divided by total number of moles, that is the solution, isn't it? The total number of moles of solution is the number of moles of solute plus number of moles of solvent. So, we can write Na plus Nb. Is it clear? Na plus Nb. Similarly, can you write in terms of B? What is it? Chi B is equal to, or mole fraction of the component B in the solution is equal to what it is? Nb, that is number of moles of that particular component divided by Na plus Nb. Is it okay? Clear? If you have n number of components, you can do this, nothing wrong. Now, the question is, what would be the sum of the mole fraction of all the components present in the solution? Can you say? What is the sum of all the fractions? It will make a whole, right? The same thing. So, you can write chi A plus chi B, that is mole fraction of component A plus mole fraction of component B will be always 1. Good. It will be always 1. Is it clear? So, the concept of mole fraction, I hope it is clear to you, right? Chi A plus chi B is equal to 1. Okay. Now, we will be trying to solve this question. Can you read the question? What is it? A tank is charged with a mixture of 1.0 into 10 raised to 3 moles of oxygen and 4.5 into 10 raised to 3 moles of helium. So, in the tank you have two gases, one is oxygen and another is helium. They are present in different concentration. One is 1.0 into 10 raised to 3 moles and another is 4.5 into 10 raised to 3 moles, right. Now, you are asked to find the concentration in terms of mole fraction. Since it is directly given number of moles, nothing to worry, you have let the number of moles of oxygen, it is directly given in the question, that is 1.0 into 10 raised to 3 mole, right. Then what is the number of moles of helium? Number of moles of helium is equal to 4.5 into 10 raised to 3 mole. Is it okay? Now what is chi O2? Chi O2, that is mole fraction of O2. It is equal to number of moles of O2 NO2 divided by total number of moles NO2 plus NHE, which you can further write it as 1.0 into 10 raised to 3 divided by what is the total number of moles? 4.5 into 10 raised to 3 plus 1.0 into 10 raised to 3, right, which you can further write it as 1.0 into 10 raised to 3 divided by what is, that is 4 plus 1 5, that is 5.5 into 10 raised to 3. Is it okay? So, what is the final value you are going to get? You will be getting the mole fraction as 0.01818, okay, 1818, and it do not have any unit, right. Now, if you know what is the mole fraction of O2, being a binary solution, only two components are there, can you easily find out what is the mole fraction of helium? How will you find it? You can subtract from 1, right. So, you will get it as chi helium is equal to what is? It is 0.8181, 0.8181. Is it okay? Shall we proceed? Okay. Next we will see molarity. Okay. It is a very useful unit for us because most of the time in laboratory we prepare solutions by taking definite quantity of a solute and dissolving it in a particular quantity of a solution. So, now let us see what is molarity. Molarity is nothing but number of moles of a solute dissolved per liter of a solution. So, how I can write it? Molarity is equal to number of moles of solute divided by what is it? Volume of solution, volume of solution in liters, remember it should be per liter, okay. So, we can define it as number of moles of solute dissolved per liter of solution. Now, you know, if it is a binary component, assume A is the solvent, okay, and B is your solute. A is your solvent and B is your solute, right. Now, number of moles of solute, what is number of moles of solute? Can I write it as NB? Is it number of moles of solute? You can express this number of moles of solute in terms of weight, that is WB. What is WB? It is the weight of the solute divided by MB. What is M stands for? M stands for the molar mass of that particular substance, right. So, number of moles is equal to given mass, that is mass of the substance divided by molecular mass of that or molar mass of that substance, right. Then you can substitute here, so that you can write molarity. It is normally denoted using the letter M. Molarity capital M is equal to WB by MB. It represents the number of moles per liter in terms of volume. It should be in terms of liter. Suppose you know liter is somewhat larger quantity as far as we are concerned when you handle chemicals in our laboratory. Most of the time for titration and all, we always take little smaller quantity in terms of milliliter, maybe 50 ml, 20 ml, 100 ml, 100 and 200, 250 ml, like that, right. So, we need to express in terms of milliliter. So, how we will do? So, we can write WB by MB into 1000 provided you express the volume in terms of milliliter, provided you express that volume in terms of milliliters. Is it clear? Okay. Shall we go to one example? Okay. Now, you read this question. Determine the molarity of 40.00 ml, that is 40 ml solution containing 0.2074 gram of calcium hydroxide in it. Read the question once more. Determine the molarity of 40.00 ml solution containing 0.2074 gram of calcium hydroxide. So, what is the solute here? It is calcium hydroxide, isn't it? The weight of the solute is given, Wb is given. What is Wb? It is 0.2074 gram, right. Now, you require Mb. For that it is mentioned it is calcium hydroxide. Can we find it out? Okay. So, what is the atomic mass of calcium? 40, oxygen 16, and for hydrogen it is 1. Okay. Now, you can substitute here, you can find it total, it comes to Mb equal to 74. Okay, Mb comes to 74, right. Now, what we will do? We can substitute in the equation directly. Can you do it? Okay, so we will do it. Molarity of the solution is equal to Wb 0.2074 divided by molar mass is 74 into what is the volume? It is 40, right. Since it is given in terms of milliliter, do not forget to multiply with 1000. Okay. Is it okay? Just let us see once more. So, I multiplied with 1000 to make it in terms of liters. Now, by solving this, you will get 0.07 molar. Okay, you will get it as 0.07 molar solution. Is it okay? Shall we proceed? Okay. Next, we will see another unit called the molality. What is it? Molality. First one that we discussed earlier is molarity, this is molality. So, there is a small difference between molarity and molality. What is it? It is defined as number of moles of solute per dissolved per each kilogram of the solvent. Remember, it is solvent. Earlier it was total solution, right, but here it is solvent. So, number of moles of solute dissolved per kilogram of solvent divided by mass of solvent in kilogram. It should be in terms of kilogram. Please remember this, it is very important. Now, you can further modify, that is number of moles of solute divided by number of moles of solute divided by what? Mass of solvent. If it is expressed in gram, then what you have to do? It is per each gram, but it is defined as per kilogram, right. So, what you will do? Into 1000. You have to multiply it into 1000, right. The same thing you can apply here. If you consider it is a binary solution, component A and B are there. As usual, we take A as solvent and B as solute. Then what is number of moles of solute? Number of moles of solute NB is equal to weight of a solute by molar mass of solute, right. Weight of solute by molar mass of solute. Now, what is the weight of solvent? Let it be WA. What is WA? It is weight of or mass of solvent. Now, you can write the expression molalities. Normally, we use small letter m to represent the molality. So, molality is equal to, what is molality equals? It is equal to number of moles. Number of moles is WB by MB, number of moles of solute divided by what? The weight of solvent. What is the weight of solvent? WA. WA. If it is in kilogram, right, okay, nothing to do. But if it is in gram, you have to multiply with 1000 to convert in terms of a gram. Is it okay? Clear? Any doubt? Okay. Now we will solve this question. A 4 gram sugar cube. What is sugar? Sugar is nothing but sucrose. Its molecular formula is C12H22O11. Okay. Sucrose. It is dissolved in a 350 ml tea cup of 80 degrees Celsius water. So, the temperature is given 80 degrees Celsius, and in that tea you added 4 gram of sugar whose molecular formula is given, that is C12H22O11. What is the molality of the solution of the sugar solution? And you are also given the density of water at 80 degrees Celsius as 0.975 gram. Read the question once more. What is the question? You are given what? The amount of solute. Here the solute is sucrose or sugar. It is 4 gram. So, you can write WB is given as 4 gram, right? And MB, is it given? It is not given directly, you have to find it. Okay. So, you know the atomic masses of carbon, that is 12, hydrogen 1, oxygen 16. So, when you put in this, and you can find the molar mass as 342. Okay. What is the molar mass of sucrose? 342. Okay. And it is dissolved in 350 ml tea. 350 ml tea is the solution. So, the volume of solution is given. Volume of solution, that is tea, is equal to 350 ml. Okay. This 350 ml. 350 ml. But you are asked to find the molality of the solution. To find the molality of the solution, what actually you require? You require the weight of the solvent you require. Is it? Mass of the solvent. But you are given what? You are given the volume of the solution, but at the same time you are provided with the density. Isn't it? You are provided with the density. So, first of all what you can do is, you find what is the weight, total weight of the solution. What is the total weight of solution or mass of solution? Total mass of solution is equal to, you know, if you are knowing the volume and the density. So, you can find what? The total weight mass is equal to density into volume, right. So, density is 0.975 into 350 into 350. So, make the concept clear, do not concentrate much on the numerical aspect, right. You first to make your concept clear, later you can practice on your mathematics. Total weight of the solute and so you got the total weight of the solution, right. It will be around 341, okay, 341.25 you got. Now, what you are supposed to do? You have to find out what is the mass of the solvent, right. You have to find out what is the mass of the solvent. So, how will you find the mass of the solvent? You know, solution is equal to solute plus solvent, isn't it? Solute plus solvent, right, solute plus solvent. So, what is the mass of solvent here? What is the mass of solvent? So, mass of solvent is equal to what? Mass of total mass of solution minus what? The mass of solute. Okay. Now, you have the total mass of solution. What is it? It is 341.25 minus what is the mass of solute? Mass of solute is nothing but it is given 4 gram, right, 4 gram. So, you can find what is the mass of your solvent. It is 337. How much? 337 it comes, 337.25 gram. Next, what you are supposed to do? You have to find the molality. Okay. For finding the molality, you can substitute in the equation. What is that equation? That is molality is equal to given mass by molar mass. What is given mass? That is molality is equal to given mass is 4 divided by molar mass is 342, right. That is number of moles you got. per kilogram of the solvent. So, what is the mass of solvent here? Mass of solvent is 337.25. It is, since it is in terms of gram, you have to multiply into 1000. Got it? Multiply with 1000. So, what is the final answer after solving this? You are going to get, you will get it as 0.034, 0.034 molar solution. So, actually what you prepared by dissolving 4 gram in 350 ml is 0.034 molar solution. Is it okay? Then one another important point that you should remember when we discuss about molality is, so when compared to molarity, molality is more reliable. Why I said it is more reliable means, you know, molarity is equal to what? Equal to number of moles of solute per volume of the solution, right? But you know, volume can change with respect to temperature. Can it change with respect to temperature? So, it is very important to specify at what temperature you are calculating the concentration of the solution. But in case of molality, we have what? In terms of molality, if you write molality is equal to, what is molality equals? It is equal to number of moles of solute by weight of a solvent or mass of solvent. Do you think mass is going to change with temperature? No, it is fixed. It is fixed, right? So, it is more reliable. That is the reason why we use a molality for most of the calculation, right? Is it clear? Okay. So, children, we will be concluding this session by this. I hope you understood the remaining methods of expressing the concentration, like parts per million we discussed today. We discussed the concept of mole fraction we discussed. Then also we discussed the concept of molality and molarity. Hope you understood all this. In the next session, I will be discussing about the solubility of solute in solvents. Okay. In that we will be focusing on the dissolution of a solid in liquid and dissolution of a gas in liquid, and related to that we will be learning the Henry's law. Okay. So, time being, I am winding up this session. Hope you understood what we discussed in this. Thank you.